In this video, we're going to find the antiderivative of arctan of x, and we're going to do it with integration by parts. Now, we get to choose our u and we get to choose our dv. Well, we're certainly not going to choose arctan of x for dv, because if we knew the antiderivative of arctan of x, we wouldn't need to do integration by parts. So, we're going to let that be our u, and that just leaves dx for dv. So not a typical choice, but really our only choice. Now du is 1 over 1 plus x squared dx, and v is left to be just x, the antiderivative of dx. So when we put this back together in our integration by parts, we have uv, so x arctan of x, minus the integral of v, so x du, times 1 over 1 plus x squared dx. Well, notice what's going to happen here, and sometimes you'll see this one rewritten. So we have the x arctan of x, that is part of our antiderivative and it's already done. This may look a little more familiar if we write it as x over 1 plus x squared dx. This is actually a u substitution. We're going to let u equal the denominator, 1 plus x squared, and then du is 2x dx. Now I don't have a 2 in there, but I do have the x dx, so I'm going to put in a 2 in my integral, which means I'm going to put a 1/2 outside. So those cancel each other out, and I haven't changed what I originally have. So we have x arctan of x minus 1/2 times the antiderivative, that's just du over u, which is one of our basic antiderivatives. It's actually ln of u. So we have arctan of x minus 1/2 natural log of the absolute value of u plus c. And last step is to substitute back and we'll be all done. So we have x arctan of x minus 1/2 times the natural log, and you do not need the absolute value because 1 plus x squared will always be positive, plus c. And there is our general antiderivative to arctan of x.